Hello and welcome to this webinar. For some of you, this will be some repetition from yesterday, but there might also be some new people joining here who wasn't there yesterday, so also repeating the information. First of all, if you have any questions during the presentations or after presentations, just write it in the chat. If you have a question for a specific presenter, just write to that specific person and we will sort it out. We'll also gather all the questions that you ask in the chat and we'll take them at the end of the webinar, not directly. As you've noticed, we are recording this, so all the presentations will be recorded, but not the talk at the end. And you will also get a link to the recorded webinar sent to you afterwards to the email that you used for signing up. And we will also conduct a couple of polls during the webinar. If you were here yesterday, it will be the same polls. Just short questions about if you're studying at which university and such. So you should sign whatever option is available for you when the polls pop up. Right, let's go through the agenda for today. So first off, I'm going to give you a short presentation about what the Geosection is, who we are, what we do. Then we're going to have the talks. We're going to first start with Måns, and then we'll go through Linnea, then Helfrid, and then finally Tobias. And at the end, we'll have the panel discussion and answering the questions that you have written down in the chat. We don't know exactly which time each of these people will start talking because it's a bit flexible. But we aim to end at around 5 p.m. So who are the Geosection? Well, we are part of the trade union Naturvetarna. I guess we're a professional association. So we are here for all the geoscientists and all the people who are working within the field of geoscience. So it's both people working with actual science at university, but also maybe people working with mining or industry. And we aim to strengthen our profession as a whole and also increase the awareness of society when it comes to geological sciences or geosciences. And we also try to get a better bond between students, the universities, and companies, and also other organizations that are connected to life that comes after university. We also aim to have more applied geoscience in our education, so it's not just theoretical, because that gives you a better basis for working outside of the strict theoretical geosciences, and also to raise awareness, I guess, of geoscientific knowledge and data, and also try to get geoscience as a subject in schools before university, because in the end it's the science of the earth as a whole, so it's critical that people understand how it works. And we do have a lot of activities and such going on, so you can find us both LinkedIn and Facebook. With that said, let's jump into the first presentation. So that is Måns. So Måns, you can share the screen whenever you're ready.
You see the presentation, right?
We do see the presentation.
Yes, and then I will start then. My name is Måns Yrkesmöjligheter, and I'm a staff geotechniker at SGI. And I shall just get up my presentation window also, so I see what I want to say. There we go. And I am a geotechnical engineer at SGI since 2018, and I studied at Chalmers at civil engineering at 2016, but I also had some courses at Luleå where I learned some praxis, and I also am a member of a Swedish Geotechnical Society. I also worked when I was done at Chalmers, I worked as a consultant in the private sector as a geotechnical engineer also. So something about I learned I haven't heard about AutoCAD and other slope stability softwares like Slope, Plaxis, and GeoSuite, but I never learned them during my Chalmers years. But I learned them at the work, so there are just some geotechnical program softwares that you can maybe need to know about if you want to work to a geotechnical engineering as your work life. And what is SGE? SGE is a state expert authority, and we are around 100 employees. And our work is to prevent landslide and beach erosion and other effects of climate change. And we also develop new knowledge about these areas, and also find new methods to clean up contaminated areas. So we have a lot of what's called förorenad jord, and people know about miljövetare. We also have a lot of those in SGE also. And one other part of SGE is to go through referrals regarding the detailed plans. And finally, we have a tjänsteperson in beredskap, where we have one geotechnical engineer on standby for the rescue services and municipalities to call every day, every hour in whole Sweden. We can also say that in SGE we have you can also work as a researcher, and we have some researches that I have been kind of looked into. It's like what is the properties of silt, and what is how it change the temperature changes of when you take up a clay sample, how it will change it of temperature from the soil to the laboratory, change the different properties of the clay, because with the temperature change, how much will it disturb, or will it disturb the sample? But more what is a geotechnical engineer, because I have learned that what people here is a geovetare instead, and geotechnical engineer can absolutely be a geovetare. But we are mainly working with settlement and bearing capacity of this and stability calculation in soils, soft soils. I'm work a lot with the clay. They are also can work in sand and silt and peat. And we also have the development of mitigation proposal and control programs for those when we build that actual proposal that we have proposed. We also do a lot of field investigations and laboratory testing to determine the soil layers and their properties. And I also talk a bit more about another way to actually work as a geotechnical engineer is in the laboratory, where I have personal interest right now, because I find it really interesting to get more advanced way to find the actual shear strength of the clay. And we have a different way to first in the process we also do is we have a routine test where we do classify the soils test and soil pack, and also do a cone test where we just drop a little cone into the clay. Then we have the CRS or the meter, where we get the modulus of the string parameters, and also the creep parameters for the clay if we do with clay. And then we also have the direct shear strength, where you can get the direct shear strength or undrained shear strength. And finally, we have here at the picture, we have a triaxial test where we have all load the clay sample in all three ways. And so you have the actual strength, and you have can get increase the pressure around the test, and where you can find or you can evaluate the undrained, drained, active and passive shear strength, and also to actually see how anisotropic that the clay sample actually is. But more about me, what I actually do is that I work at the delegation of Göta-älv. There we have about 100 million that we give in bidrag to the municipalities along the river to prevent landslides and such. And Göta-älv is, as some of you may know, is the largest river in Sweden regarding water flow. And along the river we have a lot of quick clay, and therefore we are and because of we have a lot of transport and boats, and also we have water power plants along the river. The disturbance in the flow of the river in a way will be a large cost for this society, and therefore we are giving out those millions to good prevent measurements. And we also look through all the erosionsskydd along the river. And here we at the pictures we see how it will look before along Göta-älv before they have any erosions at all, erosionsskydd along the river. You can see that we have a lot of skreds, landslides happening along the river, but this is not how it looks today. But how we do this is this work to see what the landslide prevention will do is we do these risk maps and also do calculate these preventive measurements. And we have one of the proposal that we look into right now that is in the Lilla Edet. And finally, I will just talk a bit about one of my other works we do at SGI is we have something called tjänsteperson i beredskap, where we work in emergency situations where support is given to rescue services and municipalities. And the one thing that I worked in was the Lökeberg landslide 2019, where a landslide happened, and they were wondering when can we go back to this area, and because it was it looked quite bad as you see as the picture. That was all from me. I think that's what I can have any questions about more geotechnical. You can just give it in the chat or send them to me. That was everything I wanted to say.
Thank you, Mods.
Thank you.
It's interesting to see to hear from the more technical aspects also. Now let's move on a little bit to the more solid bedrock and to Linnea. But in the meanwhile, we'll go also to have this poll. But Linnea can prepare your presentation whilst we all vote here.
Så ser det bra ut.
Ser bra ut. This presentation will also be held in Swedish, by the way. It looks like Gothenburg is actually leading this time. I don't remember if we had more Gothenburg yesterday. Maybe not. Just missing 2 people now.
Ska jag vänta lite?
Jag väntar lite bara.
Och beskåda den fina bergslänten så länge. Och tunnelpåslaget.
Ja, det får bli alldeles utmärkt så.
Ja, jag tänkte prata lite allmänt bara. Förutom att nu fick jag upp en massa polls här.
Yes.
Jag tänkte prata lite allmänt bara om min väg från geovetenskapslinjen till att nu sitta som byggledare berg. Och lite saker som jag har fått göra som geolog tidigare, nu som byggledare, samt tips och tricks och sånt som jag hade velat veta när jag studerade. Så jag hoppar rakt in, förhoppningsvis, med en fältselfie. Linnea Ragnarsdotter heter jag, 37 år. Jobbar just nu som byggledare berg på nya tunnelbanan i Stockholm. Och den del som långt nog heter utbyggnad av depå i Högdalen som ska knyta ihop Farstagrenen med Hagsätragrenen för att kunna försörja tågen med depåmöjligheter. Jag är anställd på Envila Group som konsult. De flesta av oss inom tunnelbanan är inte anställda direkt under regionen utan det är massa små konsulter. Tidigare så jobbade jag som geolog inom samhällsbyggnad på VSP. Och sen så därifrån så gick jag vidare som byggledare på TBM, eller tunnelborrmaskin. Också det på VSP. Och där satt jag och åkte runt i 2,5 år innan jag tröttnade och hamnade på tunnelbanan istället. Men min bakgrund då, jag pluggade på Geovetenskapslinjen på Stockholms universitet och tog en kandidatexamen med inriktning berggrundsgeologi och lite masterkurser som jag tyckte var kul. Tillämpad geologi och malmgeologi. Men när jag var klar på universitetet så var det extrem lågkonjunktur och alla projekt pausades i Stockholm. Så att jag läste en 2-årig YH-utbildning som anläggningsingenjör med inriktning väg och berg på akademin. Och akademin är ju mer produktionsinriktat och just fokus på folk som vill byta inriktning i livet eller bredda sig lite grann. Så det är ju väldigt fokus på produktion och kontrakt. Och man får lära sig bygglingot. För det är väldigt mycket tekniska termer när man väl kommer ut där. Och sen var det följt av 2 praktikperioder på 3 månader var. Som jag gjorde på VSP båda 2. Och därav att jag hamnade där sen efter mina studier. Så lite grann som arbetsuppgifter som man får göra som geolog. Mycket med ändelsekartering, borrkärnskartering, ytkartering, släntkarteringar, tunnelkarteringar. Mycket besiktningar och inspektioner av befintliga bergkonstruktioner för att se om de behöver åtgärdas på ett eller annat sätt. Lite radonmätning har man fått slänga in. Och det här är ju sånt som ofta är förstudier förutom besiktningarna när man ska göra ett jobb. Men sen så när man väl har byggt på den här bakgrunden och varit med på tillräckligt många projekt så klev jag in som bergtekniskt byggstöd. Och då var ju min roll främst att sitta som beställarens bergkompetens i projekt och lyfta och kontrollera att deras intressen togs tillvara. Men även som stöd mot entreprenörer ibland när de hade mer komplexa situationer än vad de hade stött på tidigare. Så hur man skulle gå tillväga med förstärkningar innan sprängningar och liknande. Och allt det här syvende och sist leder till en väldans massa rapportskrivande. För allting måste ju dokumenteras för framtiden. Och kunna levereras i en lämplig form. Så att även de som inte är insatta förstår vad som ska göras eller har gjorts. Jag slängde in lite bilder på lite olika projekt jag fått vara på. Högst upp till vänster var ett av de första jag var ute på min praktik. Det är inne i en av gasklockorna här i Stockholm. En K-märkt byggnad som skulle byggas om och saneras. Och inuti den så var det råbergyta. Sen så har vi en typisk häll till vänster om det. När man ska ut och göra ytkarteringar. Ibland är det inte så mycket mer än det där man ser. Och sen så försöker jag springa runt över ett stort område och pussla ihop till en berggrundskarta. Sen har vi väldigt fint berg som ni ser där i Boliden när vi gjorde djupförvaret i Schulte-Herbruggen. Så hoppar vi vidare. Ibland kan man även få komma ut på hög höjd och hängas upp i ett vertikalschakt som jag fick göra. Så det här är Citybanans vertikalschakt mitt i stan där vi skulle dra nya tunnelbanesträckningen till Arenastaden väldigt nära. Jag tror att vi har ungefär 3-4 meters bergtäckning mellan den väggen jag hänger på och befintlig tunnelbana eller den tunnelbanan skulle byggas. Så då var man tvungen att besiktiga vertikalschaktet för att se om det behövde förstärkas upp något ytterligare. Och sen som mittenbilden till vänster kan man hamna längs med en bergsslänt i Nordnorge om man har tur. Och få göra lite släntutredningar för breddning av en väg. Och få lära sig lite grann hur norrmännen jobbar. De har ju generellt sett betydligt högre slänter än vad vi har här i Sverige. Så att de jobbar inte så mycket med förstärkning utan mer varning. Det kan komma ner en sten. Hur mycket man nu ska göra åt det när man kommer körandes. Sen har vi en bergtäkt. Och där är det mycket materialanalys och bergartskartering för att se vilken riktning ska vi fortsätta driva i. För vilket material är det som passar som ballast. Sen kartering av ett utskov vid ett vattenkraftverk i Jämtland. Längst ner till höger, eller till vänster, här har vi även tunneln från Schulte-Herbruggen igen. Jag spenderade 2,5 års tid fram och tillbaka med att kartera och förstärka. Sen har vi en borrig i action och längst till höger en bild på hur det kan se ut när vi har varit ute och karterat. Och de späckgrupper som vi levererar visuellt då med tillhörande karteringsprotokoll. De flesta beställare vill ju väldigt gärna ha det enkelt. Sen gick jag över som byggledare. Och det var lite annorlunda att sitta som byggledare TBM. Vilket inte är så vanligt i Sverige. Så det var väldigt kul att få vara med på det första större på många år. De flesta tänker ju Hallandsås när man säger TBM. Men så ska vi inte göra igen. Ingen rockagill. Men som byggledare så är uppgiften att representera beställaren på plats. Vara ögon och öron. Och följa upp det dagliga arbetet på sajt. I en tunnel eller var man nu är någonstans. Se till att kontraktet efterföljs. Så att de följer de riktlinjer som är uppställda. Hur saker ska utföras. Och parametrar man ska hålla sig innan. Så att det gör vi främst med att medverka vid de olika momenten. Som injektering. Det vill säga tätning av berget med cement. Så att vi inte får in läckage av vatten i tunneln. Men även syn innan och efter sprängning. Samt att bergförstärkningen utförs och är rätt installerad. Det är den som är våran säkerhet också. Och sen så blir det mycket samordning mellan entreprenörer och beställare. Ofta så har ju entreprenören frågor, hur menar ni här? Eller vi har en annan idé på hur vi skulle kunna göra det här. Är det någonting ni skulle kunna tänka er? För att man kanske sparar tid eller pengar. Eller att det blir effektivare. Sen är det väldigt stort fokus på arbetsmiljö. Dels för att man vistas där själv. Men även just att man ska få till säkra arbeten i alla led, inte bara på pappret. Så vi har ju vår dagliga syn där vi kontrollerar sånt. Men det är även skyddsrond en gång i veckan eller varannan vecka. Där vi följer upp sånt här med arbetsmiljöansvarig och ansvarig hos entreprenören. Och som följd av det så är även granskning av arbetsberedningar som måste ta fram eller innan varje moment i entreprenadcykeln. Och sen så de mindre praktiska bitarna, det är att granska de utförda arbetena och sätta ihop hur mycket har vi gjort den här månaden eller kontrollera att det entreprenören vill ha betalt för har de faktiskt gjort. Och lite bilder från de övre bilden och den längst ner till vänster är från tunnelborrmaskinen. Som ni ser, det är en rätt annorlunda arbetsmiljö med en helt rund tunnel och lottad bergyta. Så det är lite en som sitter och åker runt i ett kärnborrhål. Och kunna studera geologin på nära håll. Har man tur så lyckas man hitta sådana fina rökvartskristaller som jag har där. Men det är tyvärr inte så ofta man springer på det. Och sen nedre mitten så har vi en skrotrigg från projektet jag är på nu. Och det är helt enkelt bergrensning med större maskin så att det ska vara säkert att gå in där och arbeta efter sprängning. Och längst ner till höger så har vi en nyladdad salva som ska sprängas en stund senare. Och lite tips från coachen eller sånt som jag gärna hade velat känna till när jag pluggade. Det var just att läs relevanta kurser, sånt som ni tror att ni kommer vilja jobba med. Kolla runt på de olika universiteten och lås inte fast er vid det när jag börjat. Man kan ju ofta bredda sig med en kurs här och där. Och det kan ju vara allt möjligt från lite projektledning eller varför inte lite ekonomi eller någonting också. Och sen framförallt utnyttja alla möjligheter till praktik. Det är det jag skulle vilja säga. Det ger så mycket att få vara ute i verkligheten och få lära sig. Och framförallt inte kosta entreprenören eller konsulten pengar medan man lär sig. Och visa att man tar till sig och kan vara en bidragande faktor hos dem. Så antingen hos entreprenör om man vill lära sig hur produktion går till. Eller hos en konsult om man vill se bakgrunden till hur man bygger ett projekt innan det är igång. Och så samma där, skriv exjobb på ett företag. Det bästa är om man har en egen idé, eller ungefärlig idé vad man skulle vilja rikta in sig på. Men hittar man rätt så vill de flesta hjälpa till. Många företag lägger ju även ut att de söker studenter eller liknande och även entreprenörer. Och samma sak att de lägger ut sommarjobb och traineetjänster. Så att signa upp er på sådana mejllistor där det finns, eller skicka ett mejl till HR-ansvarig och säga att ni är intresserade. Att de kan gärna få höra av sig när det är dags. För att allt är inte akademiska poäng. Så det gäller ju att tillgodose sig kunskaper på annat sätt också. Praktiska. Nu la jag lite i fel ordning för det kom jag på sent. Svensk byggtjänst, det är ju sånt som vi använder väldigt mycket i produktion. AMA-koder kommer ni stöta på mycket. Det är det som lägger grunden för alla projekt, hur det ska utföras. Och de har studentpaket där man gratis kan komma åt det här om man studerar samhällsbyggnad eller liknande. Så kolla in det. De hade även en YouTube-kanal såg jag där det fanns lite introduktion till det och bara lära sig navigera runt det, för annars är det en djungel när man kommer ut. Och sist men inte minst, använd och uppdatera LinkedIn. Även som student så är det bra att börja synas där och bygga ett nätverk. När man väl kommer in i svängen så är det där jag har fått de flesta av mina jobberbjudanden eller skapat kontakter som man har haft nytta av. Det var kort och gott allt för mig och tunneldraken, a.k.a. borriggen som vi har här nere i Högdalen.
Tack så hemskt mycket Linnea. Kul att se bilder från tunnelproduktion. Right, now we start the second poll for the day. And in the meanwhile, Helfrid can prepare her presentation. And similarly from yesterday, we have mostly bachelor students here, which is really good because you still have time to pick the best road for you. Let's see. I'm missing 2 people, but let's wait a few seconds. Right, that's all. Helfrid, the floor is yours.
Thank you very much. I am actually really enjoying listening to the presentations from the other people talking here, both Måns and Linnea, and I'm sort of wishing I'd been exposed to this during my studies as well. My name is Helfrid. I'm not German, but I'm married to one, which is why I have a very German surname. But I'm half British and I'm half Swedish, and I conducted my studies in Scotland at the University of Edinburgh, where I did a bachelor's with honours in environmental chemistry, because I was very interested in the environment and problems around us. After this, I did a PhD in environmental engineering with where I did research on water purification technology, so membranes and reverse osmosis, in order to remove heavy metals, uranium from drinking water. And I was very interested also in international development work, which is also why I did a project at some point together with the Salvation Army with the water and sanitation programs in Kenya and Malawi. And we did develop their project framework around resilience and securing water and food. So after research, you delve and you have very sort of focus on one particular question. I feel that I have broadened a lot since then. I ended up in Sweden as a guest researcher at KTH, where I also did teaching in natural resource theory and samhällsbyggnadsprocessen, so how to build our society, I suppose. And after KTH, I did projects with the Water Center in Norrtälje and eventually ended up at Yrkesmöjligheter, which is a small consultancy in Stockholm. And here I've now been for the past 5 years. Let's see if I can change my screen. There we go. Yrkesmöjligheter is quite an interesting consultancy. I think we work a lot with the development projects in collaboration with several different partners, and we apply for a lot of development funding of different types. So sometimes we work as consultants to municipalities or for private sector as well, but a lot of the time we apply for funding from different sources. It might be Länsstyrelsen, so the regional authorities, or it might be national or EU funding. And we try to bridge this gap between research and implementation. And a lot of the time we find ourselves in collaboration with academia, with researchers, but also with municipalities or with, for instance, Trafikverket, a lot of projects, which is I don't know, the road agency, what I'm going to call them now in English. I'm not using the correct name. Our main focus areas are really materials and transport. Material flows is one aspect that Yrkesmöjligheter works with. And they have developed and are developing tools for looking at how can you reuse the masses in construction projects in a better way. If you know the flows and you know the quality of the material, then you can hopefully find use for these different materials. This is not something that I'm personally involved with, but I thought as geoscience students, this could be very interesting for you to know about. And it's a lot about matching different projects, construction projects, and seeing what material can be reused so that we can attempt to move in a more circular direction, and we can also leave these long transports of material that we are now at the moment we have a lot of in Sweden. What I'm more involved in is, of course, Yrkesmöjligheter's water projects. Here I borrowed a picture from Svensk Vatten, which is the umbrella organization for the municipal water supply in Sweden. And we work on several aspects in the water cycle, and it's the water production, of course, looking at how we can deal with flooding, but also in how we can make use of the water resources or the nutrients in the water. So I have colleagues that work a lot with at the wastewater and how to reuse the resources in there. I work a lot at what we call the enskilt dricksvatten in Sweden, which is the household drinking water supply, and over 10% of the drinking water in Sweden is from wells or boreholes. And this can work very well, but there are also some challenges with this. And that can be in quantity or in quality, of course. So together with the municipalities, and this is just an example of a project that I was involved with, was to look at how can we save water, because a lot of areas, many areas in Sweden have different reasons to why the water supply, they need to work on water conservation. And there might be an actual water shortage, but it's also about the capacity of the water production. And that some areas receive a very high influx of visitors during summertime when groundwater resources are low. And a lot of our projects also are about providing examples. You know, how can you deal with your water shortage? How can you conserve water? So this is something that municipalities can use as for ideas or tips for households, for instance. And looking at water quality, it's also working together with municipalities and looking at what do they know and how can they deal with these quality issues. What advice can they give to the inhabitants, for instance, and how can they plan better in their areas? And we also looked at just water purification technologies, the types of filters that people use and that are available on the Swedish market. What kind of challenges are involved in these, and what works and what doesn't work. And here we see examples of different filters that are installed in households that are in use. And sometimes you might choose to use desalination. And there are various questions also concerning this. So at a small scale household level, it's becoming more usual also in Sweden to use small scale desalination. And something that I'm very glad to contribute to was the reworking or updating of the guide from the Swedish Food Agency surrounding drinking water quality for households. And this is, so that's an example of the type of work that we do. Just some thoughts as Måns and Linnea just also told you, that sometimes it's a challenge to find the right place, or I found that it was a challenge to find the right working place. So getting your foot in, doing some work experience is really a good idea, and just also to encourage you to keep trying, to keep reaching out. And make use of the contacts that you have. As I came back from the UK to Sweden, I found it quite challenging to just translate my experiences and my knowledge into Swedish, because, well, people might be quite used to seeing a CV in a certain way. They're looking for certain keywords. So for me, it was a very great help that just a contact shared his CV with me, and had lunch and explained a few things, and I just really found that very valuable. And in the work that you do be diligent and you know, ask until you understand what the person who you're working for is actually after. That's also appreciated. And sometimes it's not the rocket science that is that gives you the work. This might sound a bit, but I've found that sometimes it's your collaboration skills, your project management skills, your ability to actually write a report that people can read and understand is actually very valuable. However, having an understanding of how the natural world works really is a good thing, and will help you in explaining how and your understanding of what's important and how to deal with it. So that's also an encouragement. There's a lot of, as Linnea mentioned, there's a lot of writing, report writing and documentation. So certainly something to get used to. But also as encouragement, I guess I would like to say that you can find these specialist niches where you can work, or you can work more as a generalist, even with your natural science education. And that there are advantages or good things with both of these aspects, depending on your interest. And that was all for me, and feel free to ask any questions. Oh, and here's a photo of my colleagues and my email. Thank you.
Thank you so much, Helfrid. I can also reinforce the idea that it's very important to have good contacts, and some of your contacts will probably be your co-students. So interact with each other. That's a really good way to build a good network. Right. So the last poll for today, whilst Tobias is preparing for his presentation. The vast majority are obviously students, which is, I guess, not too surprising, but it's also some people who are finished with their studies already. Let's wait a few more seconds. So most of us are apparently students, but there's some of us who also have work. But that's all for now. Let's jump into Tobias' presentation. The floor is yours.
Okay, thank you very much. I hope you see the screen now.
Yes, we do.
So I was asked to talk a little bit about how I see the future and the skills that might be important for the future. So it will be slightly different from the other talks, but I will start by talking about very briefly about my own background, and then about Boliden as a company, and Boliden Exploration, which is the unit that I belong to and that this talk sort of also covers. what types of roles there are in there and for geoscientists very briefly. And then I will go into the research and development, which is my own area in the company at the moment. And then hopefully end up on some ideas for what might be important for the future as well. And then at the end, I'll throw in a slide with some student opportunities as well. So Tobias Hermansson is my name. And I am currently manager for the expert group Exploration, which is the research and development department in Boliden Exploration. I started out in Lund doing a master's thesis on structural geology in the Kaledonides in 2001. And then I did my PhD as well in Lund. There I studied the tectonic evolution of the western part of the Svekofenian orogeny in central Sweden. And I did that job as part of the site investigation at Forsmark for the nuclear waste management company. After finishing the PhD, I went on to Boliden and I worked as a specialist in structural geology and 3D modeling as well. So I worked quite a lot with developing or trying to find new ways for the company to integrate data in 3D and these kind of things. So I've just thrown in a couple of pictures of stuff that I've done during my years here as a sample. And then in 2018, I got the opportunity to actually build this little research development department from scratch. So I started out and have hired a few people, and we're now working, still looking for people. I'm hiring at the moment, actually. So a little bit about Boliden as a company. So as you know, Boliden is a metals company, and it's has the whole value chain from exploration, where I work, through mining and concentrating and to smelting and finished metal. And we also do recycling, actually, of e-scrap and things like that. So it's quite exciting company to work for, since we have the whole value chain basically, and lots of expertise in all of these areas. We have 5 mining units, which are the ones that you can see in dark blue here, in Finland, Sweden, and on Ireland. 5 smelters as well in Finland, Sweden, and 1 in Norway. We're roughly 6,000 employees in the company in total, and we're approaching 100 years now, so it's an old company. And we work basically mostly in base metals, but we also do some precious metals as byproducts. So that's about the company. And then if we go into the exploration organization, it is organized like this. You can see in the background on the map that the blue dots there is where we have offices with geoscientists working. So 6 offices in 3 different countries, and we're about 130 employees at the moment. Right now we're 16 nationalities. We've been more, actually. This is a very international group. It's exciting to work in it for that reason as well. People from all over the world. And as you can see on the organizational chart here, we have the exploration director, and under him we have 6 departments, in all of which there are geoscientists. So we could maybe start with field exploration, because that's where it starts, where we try to figure out where a new mining area is. That is then goes into near mine exploration, which takes over projects from field exploration and start drilling them to understand more exactly how much there is in there. They will eventually hand over to ore reserves and project evaluation, who calculate the resource that then can be handed over to the mines. But then we have support functions as well, exploration geophysics, for example. In Boliden, we also develop our own EM, electromagnetic systems. So we have a lab as well under this department. Geodata deals with our databases and maps and tenements and things like this. And then we have the little research and development group that I'm heading. So that's a flavor for you to see that there are loads of places in this organization where there is space for geologists. And apart from this, of course, we also have geologists at the mines in production. Those are not organized under exploration, but under the mining units. And then we also have a few geoscientists working in the sustainability and environmental departments. So there are loads of opportunities in this company. And I would say that if you want to use your whole toolkit as a geoscientist, then mineral exploration might actually be the job for you, because we actually try to understand the geology properly in the areas we're working. Of course, our job is to try to find metals in the ground in amounts that are economic to mine. And to do that, we really need to understand the ore forming processes. We need to understand the vectors towards ore so that we can zoom in on where the good stuff is. And we need to understand what has happened geologically since the ore formed as well. And all of this knowledge we then combine to try to select the best areas to explore. When we found that area, we start collecting even more information and home in on targets, and eventually, hopefully, we find something. And just to show, this is not an exhaustive list in any way, but some of the disciplines that are involved, or the knowledge base that's involved in this work, includes geophysics, petrophysics, geochemistry, quaternary geology, mineralogy, petrology, volcanology, sedimentology, structural geology. We look at tectonics on large scales as well. And then, of course, we need to make maps and 3D models, so GIS and various 3D modeling softwares as well. So we do geophysical surveys, both magnetic surveys and gravity surveys, and then we have several different EM systems we're looking at. We do bedrock mapping out in the field, and then a lot of diamond drilling, because obviously there is not outcrops everywhere, but also to get at the good stuff at depth, we need to drill. Geochemistry is done both on soil and on drill core and on hand samples from outcrops. So all of this information actually we use to try to understand where we are and where we want to go. And it all starts with research, but then as we collect this information, of course, we update the models and update our understanding as we go. So hopefully we improve with time. If we look a little bit at my group and the research challenges looking for the future, our main challenges relates to the fact that we need to find or make discoveries at increasing depths. A lot of the stuff at the surface has been found, so we need to become better at finding things at 500 meters and below that. And we want to do this with minimal environmental impact and a maintained social license to operate, meaning that the society around accepts us and wants us there, right? And there are a lot of challenges in there and a lot we can do. So one of the things we're doing is collecting new types of data that we didn't have before, and this can hopefully unlock new search spaces for us, maybe in the same areas we are already. We also look at old data, but with maybe new processing technology or new ways of modeling, and sometimes can tease out more information from that legacy data. We're trying to improve our understanding and application of mineral systems approach in both 3D and 4D, and this is basically geology, understanding the overall system where the ore forms. And then, of course, the more data we collect, we need to do something with all of this data. It's very easy that to collect a lot of data and then no information comes out of it because it's just overwhelming. So all of the new data needs to be analyzed and processed and treated in a way that it actually produces something that's useful and not just data collection. So all of this is really about de-risking the exploration process. What we do the most in exploration is fail, and we want to try to fail fast and spending as little money as possible doing that, so we can go on to the next thing. So that's a little bit about the background there. And if we look at the research and development, how we've organized that work, we have development. By development, I mean things we're doing in-house, improving data quality and working on workflows and training personnel and this kind of stuff. But the research itself is now organized in 3 different programs. So 1 data acquisition, 1 modeling and visualization, and 1 mineral systems knowledge, which is then the geological part. And I thought at the moment I think we have 13 projects going on with various research partners, universities. It's in EU projects, and we got projects with partners in Australia and Canada. Roughly 13 projects at the moment. And since I started this little group, we've actually been dealing with in total 27 projects. So we're doing quite a lot on the research side. Small projects and big projects. So just to give you a flavor, I will just give you 1 example or 2 from each of these programs. So the first one is actually a PhD project on our Nautanen deposit in Norrbotten. And here we have an in-house PhD student who worked for us before and is now doing his PhD on the job. And he's working on the characteristics of the Nautanen deposit and how it's related to porphyry and iron oxide apatite mineralization. And the end goal, of course, is to figure out how we find the next deposit. If we look a little bit on the modeling and visualization side, I mentioned 3D modeling before. This is something I've been involved in myself, common earth modeling and integrated interpretation, in which basically we're integrating all the different types of data we have in 3D, but we don't just stick it there together. We actually let each data type influence the model so that the end result is a model that honors all the different data types. So this is an iterative process going back and forth in the modeling. And the end result gives also a sort of a raster model in which each of the cells has a value for the different data types we have. So we can start querying this in various ways, and we can do quantitative mineral potential mapping and things like this in 3D with varying results, of course. It's all about how good the data is. So that's a bit of modeling. If we look at visualization, we're looking at the moment at how we can use virtual reality for mapping in the mines. So what you're looking at right now is a software that has been, or it's under development. It's beta stage at the moment, but it's been developed in an EU EIT raw materials project called Farmin. And Terranigma, as you see the logo at the bottom there, is a startup company who develops this, and Boliden and my group has been deeply involved in helping them work on this software. And this software is not just visualizing 3D models in virtual reality. It's actually a collaboration platform so that you can use almost any hardware and we can be in the same virtual space at the same time. So at the end of the day, we're hoping that we will be able to scan or use photogrammetry in the mines, so that geologists can stand up in the office in virtual reality and do the mapping and don't have to travel, and also stay out of the risky zones in terms of safety. It also unlocks the possibility for having support from an expert that maybe sits in Finland and not where I am, or something like that, to work on 3D data in real time. In the background here also, I think you saw a glimpse of a 3D model. There's a 3D modeling engine called GenPy here in the background as well. And the idea is that in the future, you will be able to actually do real-time modeling as well in the virtual space. So that's quite exciting. And then on the data acquisition part of the research, we are at the moment running a quite big program that we call the Future Logging Assistant. What we do here is combining geology with artificial intelligence and machine learning. So we're collecting, and have been doing so during a couple of years now, collecting continuous data sets of a new type that we haven't used before. We're scanning drill core. You can see up here, for example, is the Ore Explorer's core scanner, which is doing actual tomography of the core as well as XRF geochemistry. We have mineralized scanner that is an XRF scanner as well, scans straight in the core box. And then we built our own little photo booth to take UV photos of drill core as well. And we will continue working this year with hyperspectral data. So on the development side here from Boliden, my team is actually collecting this type of data, and we're looking at how we can use it as it is right now. But at the same time, we're moving those data sets over to our two researchers. So we have, we're fully funding 2 PhD students at Luleå University of Technology at the moment. And here we have Philip, who is a geologist, and we got Christian, who is a data scientist. I will come back to this in a moment, but I think this is key for the future. We're not trying to do everything ourselves. We need to create strong teams. So just to give you a flavor for what the questions in this Future Logging Assistant program, what questions we're trying to answer. I'm not going to go through all of these, but I highlighted a few. So how can we make core logging or the data collection part more efficient? This is not about making the geologist go away. It's about helping the geologist with the tedious work. How can we best amplify the knowledge extracted from each drill core by adding new data with the scanning technologies and integrating existing data using AI and machine learning? How do we promote high consistency between different logging geologists with different experience and skill? This is actually a quite big problem when you're doing 3D modeling and you're using legacy data from 30 different geologists. It's kind of hard sometimes to know which units to match up. So this is something where we hope this can help a lot. And also on our side, not so much on the research side, we need to understand how we can collect data sets that are suitable for AI and machine learning. And will that change the way we work here? And then one interesting question is how and if we can teach the tool somehow to learn to make decisions from context, because that's what we're doing as geologists. And I will come back to that in a moment as well. And then just another question at the bottom here, which maybe is not that obvious, but how do we know if we're successful in this project? How do we measure that? It's not that easy. So those are some of the questions we're dealing with here. So moving on, what skills will be important in the future? Well, to start with, geology is complicated, very complicated, and we should be kind of proud about of what we're doing when we're working. That's something we're realizing now that we're working with the machine learning as well. It's more complicated than many data scientists seem to understand anyway. We've scared a few on showing them what we're doing and trying to make them understand. So the understanding of what we're looking at when we're mapping or logging, that doesn't only come from the integration of data and information that you collect from the sample you have in front of you. You actually make decisions based on other things, based on things you've seen in the area locally that can inform you, and you've seen a contact between two different rock units somewhere might make you decide that what you're looking at right now is rock type 1 and not B. You also have the context of what you know from before you've seen from similar systems. And this is really fundamental to be able to interpret geology correctly. When we feed the information into the computer for AI and machine learning, it will see what it has in front of you. It's the data right there. So how do we get this context to come in there? And this is an obvious thing that it's not going to be easy, and the human certainly has a place in this. So you don't have to be worried that the geologists will go away. You are super important. And that's my point here. Do not underestimate the importance of properly understanding the geological data. Geologists are important. So going forward, I think that as a geologist, you need enough understanding of how AI and machine learning works to be able to communicate with the data scientist. You will definitely not have to write code, but you need to have a common language. And this is something where we're learning at the moment as well. There's been quite a few funny misunderstandings between us and the data scientists. But that is something, go a little bit deeper into understanding what happens in AI and machine learning can help you with the communication. And I think that's important. The most important point here is that solid understanding, and I mean solid understanding of geology, geochemistry, structural geology, geophysics, all the things I mentioned before, and hands-on experience from the field. All of these are key to be able to be this person that can help the data scientist to create the algorithms and that we are going to use in the future. And you're needed to create the training data for these tools. And also when it spits something out in the end, who's going to tell when there's a flaw? Well, we need to really understand geology. So old school geology is not dead. I think there is a real risk that the expert geological knowledge is lost when we're starting to trust computers too much. And this might, or actually it will inevitably lead to shit in, shit out. You've heard that before about things. So solid understanding of geology and geological processes, it's still needed. And the other thing is, I've already touched on this several times, but no one knows it all. So the key in the future is to build teams with strong competence in both data science and the geosciences. And these teams needs to work well together and understand each other. So for this reason, I think teamwork skills. And now when I'm saying teamwork skills now, I don't just mean that at the university you get some assignments together in a group and you try to solve this. I think a good thing to do is to think about yourself. You will never be able to change anyone else, but you can change how you function in different ways. That's the only thing you actually can influence. So think about, how do I function in a team? and get to know yourself. What roles do you normally take? How does that affect the group? How well do I communicate with people and listen? This is always two ways. And how can I improve? And by doing so, contribute to a positive atmosphere and in a team, and bringing that efficiency that a really good team can give. These are things that I don't know how much you get of this at university. I certainly didn't get much when I was doing my studies, but I think these soft skills are going to be very important. So it's also something that you can look into on your own. There's a lot written about these things, and just reflecting as well, and thinking about this in different situations where you find yourself in teamwork. So those are really the takeaways I want to give you from me. And then I'm going to end with, I have a thanks for listening slide here at the end, but I think I end on this one so it can stay up for a little bit. But I just wanted to show you that in Boliden we do have the possibilities for internships. We don't do that very often, and it's very ad hoc, so you have to be lucky. But don't hesitate to send me an email if you're interested in stuff like that and you have ideas. Master's projects, we do around 4 to 5 of those every year. It's a bit the same there. You have to be a bit lucky, because we need to have a good project here in Boliden to do it, and we need internal supervisors and time as well. So you need a bit of luck, but please send a CV and personal letter to me if you're interested, and do it well in time, because the more time you have, the easier it is to get lucky with the timing, I suppose. And then I want to just flag that we also do summer geologists, which is the paid job during the summer, helping with mapping and sampling and other exploration related work. And this is always advertised on the Boliden career site. And normally it comes up in February. It might already be up there, so I haven't looked recently. But if you go into boliden.com and career, you can see if there are any advertised summer jobs there. This is, of course, also where you look for normal job applications. So keep an eye on that site for the future. That's all from me. So thank you.
Thank you, Tobias. That was very thorough. I would also like to add that the challenge of having consistent mapping and consistent interpretations of bedrock overall is a challenge we also have in infrastructure and applied geology. So that's always something we need to work on as a geologist as a whole. Right, so now we are slowly moving into the panel and question phase. We have received some questions yesterday, only a few today in the chat. So if you have any questions, just write them in the chat and we'll sort them out and take them as they come. We'll also repeat some of the questions